Hi, my name is Fraser and welcome to GPU Solutions. So as you can see, we have this RTX 3080 over here, and this is a Zotac Amp Holo RTX 3080. This is a 10 gigabyte model, and this is an LHR GPU. As you can see, there are cracks here. This particular GPU was dropped, and what happened is that this card is already damaged. So I've already worked on this card before, and this was completely broken. I've stuck this into place so that it can hold. It does hold now, but the problem is this. The main thing here is that this video is not about just repair of this particular GPU. I'll just give you a background of this GPU. I've already worked on this GPU, and this particular GPU has a fault on one of the memory channels, that's B1. I've already replaced the memory, and I've already reballed the GPU core. I've replaced the memory, reballed and replaced the memory twice, and I have already reballed the core. But the problem still shows on that particular channel B1, indicating that this particular core is damaged, probably because of the drop. This particular GPU was also copper modded. That could have also added to the problem. I've already removed the copper mod from this one, and it's now just a plain GPU. As you can also see, there are some there's bend over here. It's not straight. But this is the least of the problem. But today's video is not about just a normal repair. But what we are going to do is now this is an LHR GPU. Today's video is about converting this LHR GPU into a non-LHR. I have another GPU core, which I would want to go ahead and install, but the core that I have is a non-LHR core. But the problem is just by directly swapping the core from LHR to a non-LHR is not the only thing. It will not work. This core is already reballed, as you can see. It's already reballed. Now, the thing is, on a 3080 10 GB, there are two empty slots. Those two empty slots can be on anywhere, like, like channel D, channel E, channel F. Depending on where they are, there is a marking on the GPU core, which slot needs to be left empty. I will show it to you in detail when I open this card up. So first thing first is let's go ahead and open the card up. I will not be running the memory test right now. I've already done that, and I can tell you B1 is the faulty memory. So I will go ahead and open the card up. I will show you what exactly I mean. So this card does not have thermal paste right now. I've already gone ahead and removed the thermal paste from there. And I've just put a cotton pad just to give it some kind of cushioning. So eventually this entire cooler is going to get replaced because it's pretty much useless. As you can see, this is the cotton pad just I had put just to give it some kind of cushioning so it doesn't scratch the surface. Or for me, it really doesn't matter if it scratches the surface because this core is already dead and it's pretty much useless. So let's take a look. Let's first open the GPU completely, dismantle it. Okay, so this I can straighten out later. It's not that bad. I can reuse this. Okay, so if you take a look at the core, let me show it to you under a microscope so it will be much more easier. Okay, so if you look at the core has a marking here that says GA102. So this entire die is GA102 die, which is the largest die that the NVIDIA produces. And 202, the number 2 indicates that this is an LHR core. This is not a normal core. KD, now the D, the alphabet D indicates which slot is empty. So this is the channel D, which is empty. So that indicates, so if it was channel E, it would have shown KE, and if channel F was empty, it would have shown KF. The same thing with here, if these two channels were empty, it would show KA, KB, and KC. So A is this one, A1, A0, B1, B0, C1, C0, D1, D0. So D1 and D0 are empty, so that's KD. The replacement core that I have, okay, so now this is a 200, that means this is a non-LHR core, and KD, that means that's the same slot, which is disabled on this core as well. So this core and this core, both, even though this one is LHR and this one is not, they both have the same slot, which is disabled on the core. So since both have the same slot disabled, I can use that particular core, that is this particular core, as is, and then I can just go ahead and swap the BIOS. So by doing so, I should be able to get this card back working again. So let's go ahead and prepare the port. So right now, this had a copper mod, and as you can see, this thing is filled with this is all flux, but there's a lot of paste that is underneath these GPU modules. Now, I would have to go ahead and reball all of these because it's going to really mess about, all the pads. But yeah, so the faulty memory that is showing is on this one. That is this one. That's B0. So as you can see, it has a different memory that's installed. So all these ones are starting with IO, and this one is IR. So this is a memory that I've already replaced. So I've already tried replacing two other memories before, and I've also reballed the GPU core, but that hasn't solved the problem. So the difference between LHR and non-LHR GPU is inside the core. Okay, so that's the only what differentiates these two GPUs. So this one is an LHR, so that indicates this number 2 at the end, whereas this one is a non-LHR, which just indicates just indicates a 0. Okay, so let's prepare this board so that we can go ahead and swap it out. So there are two things we need to do to get this GPU, which is an LHR GPU, converted into a non-LHR. Okay, so luckily I have this core for the 3080, and this is just a donated board that I had because it's a dead board and cracked shroud and cooler damaged. So I will have to go ahead and replace that, but yeah, I will replace this core first. Let's see if our conversion works. So it's just going, because there's no other circuit on the board that differentiates, or which has extra circuit for LHR and non-LHR. No, it's all the same. So the only difference is on the GPU core and the BIOS. So we are just going to go ahead and swap the core and flash the BIOS with a non-LHR BIOS, and let's see if that works. So let's go ahead and prepare the board first. Okay, so first thing first, I'm just going to plug this in because I would need this to clean the PCB later. But first, to remove the core, I'm just going to put in some flux. Okay, I think that should be enough. And now this is going to go on the rework station so I can remove this core. Okay, so our board is on the rework station. So let's go ahead and proceed to remove it. Starting the process now. Okay, so the process has started. We'll wait for it to finish. Okay, so the board is still hot and the temperature is rising. So let's go ahead and prepare, this board, clean the solder pads and get this board ready. So I'm just going to put some flux. So this is already leaded solder, so I don't have to tin it. So what I'm doing right now is I'm just removing the excess solder, so it's easier on the solder wick to take care of the rest. Now it's time for cleaning. I'm just going to use my magic cloth. Okay, so that looks good enough. Now, next thing, what we are going to do is leave this board at the side, let it cool down a bit, and we are going to go ahead and add flux to this particular core. So this core is already reballed. Let me switch. So this core is already reballed, and the only thing we have to do is add some flux to wet it. Looks good to me. Let's add some flux. So whenever you're reballing, make sure you add some flux to the core or the chip itself. It's a good practice. What it does is it makes sure that there's the pads that these connect to, they form a good joint. So just make sure that there is no dirt or anything of that sort within the pads or within the solder balls, because what's going to happen is if there's any debris or anything of that sort is going to create problems. Okay, this looks good to me. Let's go ahead and apply some flux to the board as well. Okay, so this looks good. Let's place the core on the board. Make sure it's aligned properly, because there is no automatic alignment on my machine, so we have to do it by hand. Okay, so this looks good to me. So I'm going to place it on my rework station back again, and we are going to continue from there. Okay, so the board has been placed on the rework station. Let's set it up. Okay, so it looks good to me. Let's go ahead and start it. Okay, so this is going to take about 8 minutes, and I'm just going to wait for it to finish. Okay, so the board has cooled. It's time to take some measurements and see if everything is okay. First thing first, let's check resistance. Okay. So first, resistance. Let's check 1.8. Looks good to me. Let's check PEX. Looks good. Let's check memory. Memory is here. Looks good. Okay. So this is just one part of the story. Now next. Okay, so this is the old core. We'll just keep it aside. We'll come back to it later. Let's connect the power supply. Okay, so let's go ahead and check the power drop. And you can see it's about 1.8 amps. Let's measure the voltages. 1.8. I have 1.8. PEX. I have PEX. Let's check the core. I have core and memory. This memory. Here, I have memory. Okay, so the next step is to swap the BIOS on this. So I'll quickly remove the BIOS. Okay, so I'm going to remove this chip, put it on my thing here, put it on this and flash it. So first what I'm going to do is just going to make it easy for my tool. So I'm just going to mix it with leaded solder so that the temperature decreases. I don't have to use too much of heat to remove the BIOS chip. Okay, finally it's out. Look like looked like it had glued to the board. Okay. So this is a very thin board, so it doesn't require much heat. It will, so you can see the solder is still melted, even though it has been so almost a minute. So it still retains the heat. So I'm just going to wait and blow some air on it so it dries down and it holds the chip. Okay. Okay, so I have gone ahead and flashed the BIOS. Let's remove the strip. Okay, let's look at pin 1. I think pin 1 is this side or this side. So a chip should be facing this way. Okay, so I'm just going to wait for the board to cool and then we will test it on the bench. Okay, so our GPU is installed on the bench. It has cooled and let's run mods again and let's see what happens. So on this, the USB that I'm using is a UEFI USB, not the legacy. Normally I use the legacy, but this time I thought let's use the UEFI. Okay, first I'm going to switch to the internal directory. And I'm going to run mods. Okay, so that's the mods command. Let's see what happens. Nice. Let's reboot and switch to the GPU. So I'm going to switch now to the GPU. Let's check if we get a display. And we have a display. Okay, so I'll just assemble the cooler and let's see how it goes. Okay, so our GPU is booting. The next step is just to clean this PCB. So this is not a customer's PCB. This is a donor board that was sent to me because the core required a replacement. So the user did not want to go ahead and bear the cost of the core. So yeah, so this was an experiment to check if can we convert GPUs which has an LHR core, can we convert to non-LHR? And let's find out after we have gone ahead and swapped or assembled the GPU, and we'll run a few tests. Let's see how it goes. And does it show non-LHR now? So I'm going to install the same broken cooler for now, at least, and probably later on I will change everything. I think I can go ahead and replace these because this plate is going to remain the same. The only thing that's going to get replaced is this particular shroud that is on top, because it's already falling apart. But yeah, so only this top shroud is going to get replaced. Rest everything is going, this cooler is going to remain the same. This is going to remain the same, and the frame is going to remain the same. It's just this, and I think I can use the thermal pads. And if I look here, I think it's using 3 mm at the back. So right now I'm just putting it all back together just to do the test. Otherwise, the rest, because there's a bend on this IO shield, and the shroud is broken, so this shroud is going to get replaced. The IO shield will be straightened, so all that's for later when I receive the shroud. And right now it's just that I wanted to test if this modification is going to work, and we will see. Okay, so this fan is not working, it's broken. These two are working, this one is dead. So let's see how this goes. Okay, so our GPU is on the bench. Let's boot it up. So as you can see, the center fan is not working. Let's wait for the drivers to load. You can actually hear this fan making that sound. Eventually, this fan will have to be replaced. There's no two ways about it. Okay, the drivers are loading. Let's see what happens. Okay, the drivers have loaded. Let's take a look at this. Does it say LHR? Or the LHR is gone? There you go. So it does not say LHR, and we have everything working properly. Okay, I'm just going to run a small test just to see how it responds. Everything looks to be good. The power draw is good. Okay, so the temperatures would be on a slightly higher side because one of the fan, the center fan, where it's supposed to cool the core, is not working. So yeah, that will eventually rise. But yeah, let's run superposition. Okay, so far everything is looking good. As expected, I did not see any crash or anything of that sort, but it's still too early. It's just the first benchmark that I'm running, so I'm going to run this benchmark. Apart from this, I'm going to run 3D Mark Nomad and 3D Mark Speedway, and then loop back again with these same benchmarks at least 2 or 3 times, just to make sure everything is smooth and this GPU is perfect. But apart from this, I think we are done. So we have successfully gone ahead and transferred or transplanted a LHR GPU and converted into a non-LHR by doing a core and a BIOS swap, and it was successful. So that's it for this video. I hope you like it. Yeah, I hope you learned something from this video. If you did, please hit the like button and don't forget to subscribe to this channel. So thank you for watching. You have a good day. Bye for now. Cheers.